Hello, and welcome to the Newark Museum of Art's Dynamic Earth Snapshot lesson. My name is Miss Mary, and I'm the Senior Museum Educator at the Newark Museum of Art. In this lesson, we explore evidence of how our planet undergoes changes over short and long periods of time, and how life adapts to those changes. Scientists collect information through observation and experiments to learn more about our world. This is how they test out ideas and is a part of the scientific method. Scientists ask a question or make a prediction. They perform experiments and/or collect observations. They record their findings and then develop an explanation for what they're seeing. Through observation of the changing face of our planet and the adaptations we note in both plants and animals to their environments, we discover that our Earth is a very dynamic planet. In this lesson, we begin by exploring sedimentary rocks commonly found in New Jersey. We discuss how they form and how changes in the surface of our planet can happen slowly or suddenly. We then compare two biomes found on Earth to discover how life has adapted to the ever-changing surface of our planet. Lastly, students are given an opportunity to sketch the habitat in which they live, and, as an extension activity, students make models of sedimentary and metamorphic rocks. Observation and discussion are powerful tools that enable students to develop the skills to acquire aesthetic and language literacy. These skills aid students when sharing their interpretations of scientific specimens to understand the world around them and to gain confidence in their own ideas while engaging in a thoughtful, respectful discussion with their peers. Before discussing each image, take a minute or two to slowly and quietly observe the image. Each image represents a part of our natural world. Think about how the image mirrors a specific moment in time in nature, and through observation and information gathering, we can learn more about our changing world. Then ask your students to share their observations. So take a minute to quietly observe the image. Some seed questions for your students are, what do you notice about the rocks in this picture? How do you think they formed? Have you ever seen rocks like this? How would you describe the shape of the rock? Does anything seem strange? Pause the video here to allow for individual observation and class discussion. The earth beneath our feet is constantly changing, and we can see proof of this in the types and shapes of rocks we find. In this image, we see examples of sedimentary rock. This is one of the three main types of rock we find on Earth: igneous, sedimentary, and metamorphic. Sedimentary rocks are formed at the surface of the Earth, either in water or on land. Since New Jersey was once underwater, we find a lot of sedimentary rock here. Sedimentary rocks are forming all around us all the time. Their layers are made of pieces of rocks and minerals, or animal or plant material. Sand and gravel on beaches or in rivers look like the sandstone they will become. Most sedimentary rocks become cemented together by minerals and chemicals. Compacted and dried mudflats harden into shale, and shale is commonly found in the ground of New Jersey, and we can find seashell fossils in the shale, proving that New Jersey was once underwater. The layers of sedimentary rock are laid parallel or nearly parallel to the Earth's surface. Imagine it like a stack of pancakes. If the layers are at high angles, like we see here, some kind of movement of the Earth occurred since the rocks formed. This movement can happen over a long period of time, or, like in this example, it can happen quite suddenly. So if the ground beneath our feet can change slowly or suddenly, how do you think these changes affect life on Earth? The global environment of Earth has gone through many changes over hundreds of millions of years and is directly affected by the changing surface of our planet. Areas once underwater are now found high in the foothills of mountain ranges. Erupting volcanoes cover their surroundings in lava and ash. Temperature changes have caused once green and fertile land to change to desert. These changes can happen suddenly, like an earthquake in California, over a few decades, like we see here at the Peterson Glacier in Alaska, or over millions of years with the formation of mountain ranges. Whether the changes are sudden or slow, life must adapt to survive. Let's explore some different places called biomes found on Earth and learn more about how plants and animals have adjusted to the changing world around them. So what is a biome? A biome is a distinct regional or global community of plants and animals that have physical characteristics and adaptations that are well suited for their environment. These aid in the survival and the continuation of the species. There are 5 major biomes we find on Earth. They are aquatic, desert, forest, grassland, and tundra. A biome can contain many ecosystems. An ecosystem is the interaction of living and non-living things in a particular environment. For example, a forest biome includes both evergreen forests found in Texas and the tropical rainforests of South America. These are both forests, but have quite different climates. Within a biome, we can find habitats. Habitats are local areas where plants and animals make their homes. The main parts of a habitat are shelter, water, food, and space. A habitat can be as large as a forest or as small as a backyard tree. So let's explore 2 biomes and discover how the plants and animals within have adapted to their environment. Take a minute to quietly observe the image. Some seed questions for your students are: what do you notice in this scene? What do you think is happening? If this were a photograph, what do you think happened next? Where do you think this scene is taking place? Describe how it might feel to be there. Pause the video here to allow for individual observation and class discussion. A savanna is a tropical grassland biome with warm temperatures year-round. They tend to be found between the desert and rainforest biomes and they're mostly located near the equator. The largest savanna is in Africa. Savannas are also found in Australia and in North America. In savannas, grasslands or grasses and small dispersed trees make up most of the plant life, so there is no large canopy which allows for sunlight to reach the ground. Since they tend to be found near the equator, they also receive more direct rays of sunlight throughout the year. Carnivores, which are meat eaters like lions, hyenas, and leopards, feed on herbivores, which are plant eaters like gazelles, cattle, and warthogs. Herbivores like elephants and zebras eat producers, which are grasses and other plant matter. Scavengers and decomposers break down organic matter, making it available to the producers, thus completing the food cycle in this biome. Many animals use camouflage, which is blending into their surroundings, to hunt prey or to evade being hunted. Are any of the animals in this image using camouflage? Let's compare our African savanna to another biome found on Earth. Some seed questions for your students are, what do you notice in this scene? How does it compare to the previous one? Who is the hunter and who is the prey? And why? How do you think these animals adapt to their environment? Do you think the lioness or gazelle from the savanna would survive in this biome? Why or why not? Pause the video here to allow for individual observation and class discussion. The Arctic tundra is found in the northern hemisphere, encircling the North Pole and extending south across parts of Alaska, Canada, Russia, Greenland, Iceland, and Scandinavia, which is Norway, Sweden, and Finland. It is a very cold, windy, and mostly treeless biome that's snow-covered for much of the year. Tree growth is hindered by low temperatures and short growing seasons due to this area receiving the least direct rays of sunlight throughout the year. In fact, in some areas of the Arctic tundra, there are periods of time where the sun does not rise above the horizon and it is dark all day long. This makes the winter in the tundra about 8 months long. There are over 50 species of animals that live in the tundra, but many migrate south during the long winters. There are a few animals that have adapted to survive the long, harsh winters, like the muskox, the Arctic fox, and the polar bear. Some adaptations we see in the polar bear are it being a large animal with extra layers of fat, so it's able to retain energy and stay warm. It has thick fur to help it keep warm, and it has large paws to help it walk over the snowy and rocky landscape, and also it uses its paws to dig for food underneath the snow. And a polar bear's fur can change to white or blue-gray in the winter and dark brown or darker bluish-gray in the summer. Today, the tundra is a very fragile biome that is shrinking as the permafrost melts. Permafrost is frozen ground in the tundra. To give you an idea of what this means, in the summertime, you couldn't dig more than 2 feet into the ground. Anything below that would be frozen solid. At least, that's the way it used to be. Due to increases in global temperatures, melting permafrost is causing a rise in sea levels and erosion, causing damage to the environment and hardships for the animals who live there. Many animals use camouflage, which again is blending into their surroundings, to hunt prey or to evade being hunted here as well. Which animal that you see here do you think is using camouflage to hide in this scene? Now it's your turn. We've explored 2 different biomes found on Earth and discovered the ways animals and plants have adapted to their environment. How do these places compare to where you live? New Jersey is part of a biome known as a temperate deciduous forest. But you may live in a habitat within that biome that has very few trees or wildlife. As a writing and drawing exercise, take 10 minutes to sketch and label your local habitat. Remember that a biome is a large regional area and a habitat is a local area, and both include animals, plants, and resources found in their environment. So take about 10 minutes to sketch the habitat in which you live and include label examples of the 5 main parts of that habitat: your shelter, your food, your water, your temperature, and your space. As an added exploration of our ever-changing Earth, we've included an extension activity in this lesson. You can pause the video here to allow your students more time to complete their writing assignment before moving on to the extension activity. Making models of rocks, using simple materials to create examples of sedimentary and metamorphic rock. Through this extension activity, students will explore how to make models of sedimentary and metamorphic rock, but their supplies will be what is available to them. Students may use multiple colors of Play-Doh or make their own activity dough to create the models. A recipe to make homemade activity dough is included in the lesson outline. When finished, the dough can be left in the open air to dry. It is important to note that the dough is not edible. Make some activity dough according to the recipe included in the lesson outline. If you have Play-Doh, choose 4 colors to use for this activity. You want to form 4 balls of dough, each about 2 inches in diameter. If you've made your own activity dough, add food coloring so that you have 4 different colors of dough. If you're using already pre-made Play-Doh and you have 4 separate colors, you can skip this step. Take one of the dough balls and flatten it slightly, as shown in the picture. Do the same with the remaining 3 dough balls and stack them one on top of the other. Try to separate light colors so that your layering will be easier to see. So in this example, notice that we've separated the lavender and the pink by the blue so that we can see the lavender and pink a little bit easier. Place your hand on top of the stack of dough and press down gently. Flatten the stack until it is about half of its original height. This represents the compression force the sedimentary rock feels as more layers are added over thousands to millions of years. With adult supervision, use a butter knife or a plastic knife to carefully cut the dough from top to bottom, like you would a cake. Examine the inside layers of your rock. What do you notice? Congratulations, you've made a model of sedimentary rock. To make a model of metamorphic rock, take half of your sedimentary rock and bend it into an S shape. This is an example of how rock can be folded and compressed. Now bring the back part of your dough up to the top and roll the dough gently into a ball. These motions represent more of the folding and pressure sedimentary rock undergoes as it changes into a metamorphic rock. With adult supervision, gently cut the ball of dough with the same butter or plastic knife as before. Examine the layers. What do you notice? Congratulations, you've made a model of metamorphic rock. How do the layers of your sedimentary rock compare to the ones in your metamorphic rock? Why do you think they look this way? Set your dough out to dry in an area where children and pets will not be able to eat it. That ends our Dynamic Earth Snapshot lesson. We hope you enjoyed your time with us today. The Newark Museum of Art is a great resource for art, science, and artifacts from the galleries of Arts of the Ancient Mediterranean, Global Arts of Africa, Global Arts of Asia, Native Artists of North America, Early America, the Gilded Age, Harlem Renaissance, Contemporary American Art, Dynamic Earth, Empowered, and the Allison Leonard Dreyfus Planetarium. For more information on events like Art After Dark, Camp Newark Museum, community events, and educator evenings, please see our website at newarkmuseumart.org. You can follow us on the social media sites Instagram, Facebook, and Twitter. We'd love to see how you use our offerings in your classroom, so be sure to hashtag or @ us at Newark Museum Art. Thank you for joining us today.